Hello all, welcome to my channel. In this video, we will see why capacitors block DC. So let's get started. To answer this question, you have to understand what a capacitor is and what a DC signal is. I have already done a video on visualizing a DC signal. It is displayed on the top right of the screen here. I recommend you to watch that before seeing this video. To understand what a capacitor is, it is nothing but a device with two conductive plates which are parallel to each other. So this is plate 1 and this is plate 2, and they have a gap which is non-conductive. That means charges cannot flow from this conductor to this conductor directly. And you have two wires connecting to each plate, and usually there is a non-conductive material between these two plates which is called a dielectric. To understand how DC signals behave with capacitor, let me draw one of the plate a little big so that we can see the charge movement. Say this is the plate and this is the wire, and these are the electrons in the wire. Now, as we all know, for a DC signal, the electrons will move in one direction. Let's assume that the electrons are moving in this direction. When a current or a voltage is applied, the electrons moving in this direction have nowhere to go apart from accumulating on this plate. Initially, a plate will have no extra charge, so electrons flowing in this direction will easily accumulate on the plate. So let's assume in the first 1 second, this is just an assumption, assume that 1 million electrons accumulated on this plate. Okay, and from 1 second to 2 second, the number of electrons that are going to get accumulated on the plate will be less than the previous number. And why is that? That is mainly because negative charges repel negative charges. So if there are two electrons, they try to push each other away. So as and when electrons start accumulating on the plate, they are going to oppose the new electrons that are going to come and accumulate on the plate. So as time passes, say this might be 0.8 million, and at this point you have 1.8 million electrons. From 2 to 3 seconds, since there are more electrons now, the repulsion will be more and even less electrons will accumulate, say 0.5 million. At this point you have around 2.3 million electrons in total, and in the next 1 second there will be further reduction in the number of electrons that are going to get accumulated on the plate. So this keeps on continuing until there will be a point where the number of electrons on the plate is so large it will oppose any new electron from coming and sitting on the plate. That is when we would call the system to be in equilibrium. So if you are applying a voltage or a current to this wire, at this point the opposition applied by this plate is equal to the force applied by this signal, and since both of them are equal, the electrons can no more come and accumulate on this plate, and at this point we call the capacitors to be blocking the DC signal. Let's look at a familiar graph. I think most of you would have seen this graph. This is a capacitor charging versus time graph, voltage versus time, and if you have a voltage source, DC voltage source, uh, trying to charge a capacitor, initially the voltage on the capacitor will be 0, and that is depicted in the graph here, and in some time, as the charges move and accumulate on this plate, the voltage across these terminals will increase, and after some time t, it will have a voltage V1, and after some more time it will almost have the voltage V. If you notice carefully, to reach a large voltage V1, it took only a small amount of time, but to make up to the small voltage V minus V1, it took a large amount of time. This is because of the repulsion of the electrons. By the time the voltage on the capacitor reaches V1, there will be a large number of electrons on the plate, and these electrons will repel the new electrons that are trying to come and sit on the plate. At that point, the number of electrons sitting on the plate will keep on reducing, and that is the reason it takes a large amount of time to reach the final voltage V. And once the capacitor reaches the voltage V, there will be no potential difference between this point and this point, and hence there will be no current flow. And we saw this intuitively through the charge moment as well, that when the number of charges on the plate is quite big, it will oppose the new charges coming in. At that point there will be no charge flowing at all, and we call the system to be in equilibrium, and this is the reason why capacitors block DC signals. So that's all for this video. In my next video, I'll be answering why impedance of capacitors vary with AC frequencies. Till then, stay tuned and subscribe to the channel. Thank you.